Hello, good evening everyone. Am I audible? Okay, thank you, thank you. So let's wait for 5 minutes more so that if someone wants to join, then they can join, then we will start this week lecture. Okay, all right. Is my screen visible to you?
Yes, ma'am, visible.
Okay, 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 done. All right. So welcome you all again, once again in the course series for Introduction to Machine Learning, instructed by Professor Balaraman sir from IIT Madras. So here we are in the week 6, and today we are going to discuss about, this is week 6. Okay, we are going to discuss about decision trees basically. So decision tree is one of the algorithm, like we have studied support vector machine. So it can be used for regression as well as classification. So we will be seeing how it will be working as regression trees or classification trees, what is pruning and what is the splitting. So basically this whole week content is completely dedicated to decision trees. So first of all, let me give you an recap for that. Um, First, we have started with introduction. Then we have completed the paradigms of supervised, unsupervised, and reinforcement. We started with the supervised paradigm, in which we saw that there are two types of task. First is classification, second is regression. So, classification when the output is in the form of a label, and regression when the output is in the form of continuous number, right? So we have started with regression type of problems, have seen linear, multiple, and other type of variants of regression. Then we have started with this classification problem, in which we have seen perceptron, support vector machine, some linear discriminant analysis. So from these two aspects, last week we studied about neural network, which is an algorithm which can cater both of the problems. So at this stage, we have now an understanding that how machine learning works, how formulation of machine learning problem works, and basically we have to have some optimization function, right? So in regression problems, generally we have mean square error function, and in classification problems we have MLEs, that is maximum likelihood estimation problem. Why? Because in regression, the output is in the form of number. So let's say I want to predict the temperature of tomorrow. So the temperature of tomorrow can be 46.5, 46.05, and your prediction may be like that 47, 48.0. Okay, 48.2 maybe. So the difference is calculated in the terms of error, and we generally use mean square error because this square term is a convex function and easy to optimize as a minimization problem. So, but for the classification type of thing, we have some classes, let's say A, B, and C. So we can't have an error type function here. So what we choose here is to describe these classes in terms of probabilities. So that's why we have an understanding of maximum likelihood probabilities, which is based on Bayes theorem. So conditional probability theorem. So this is what we have discussed till now. Okay. Presently, in this week, we will be starting a new algorithm that is called decision tree. So decision tree is not specific to machine learning. It comes from the statistical theory as well. And many analytical tools also use this type of decision trees to make decisions. Okay, so let's start with these decision trees. So this is what is decision tree? It is used for classification and regression, both the task, and obviously the term is here as tree. So tree is some hierarchical structure which can be represented as nodes, and those nodes will be representing some decisions. So that's why this tree like architecture, which helps you to take some decision, that's why they are called as decision tree. Okay, so you can see a decision tree here. So I think most of you have known this term decision. Anyone who have not heard this term decision tree, or tree is not familiar, who is not familiar with trees. I'm not talking about technicalities, but I think you all have an understanding what trees are, right? Is anyone who don't have any understanding? Okay, fine. So basically you can see here the tree, dummy tree is given to you. So there are some components of any type of tree actually. So because this tree will help you to take some decision, that's why we are calling it a decision tree. Otherwise all the other things, that the properties of some trees are present here also. So first thing is root node. So the most important thing here is root node, because this root node will decide how to go further deep down in the depth that can represent your data. Okay, so this root node is very crucial, right? So this root node is the node which represent your entire data. Okay, so it means that trees are composed of these nodes and these edges. Okay, so this is your first node is root node. Second is decision nodes. So except this root node and the final leaf nodes, the intermediate nodes are called as decision nodes, because these nodes will help you to take decision and they can help you to increase the depth of the tree as well. Okay, so decision nodes are intermediate splits based on the features. So you can say that let's say this root node is let's say climate. Okay, so climate can be hot, cold. Another is let's say humidity. So this humidity can be high or low. Okay, so in this way we can have multiple features on the decision nodes, but root node is the most important features out of your data set. And finally, these leaf nodes, which are represented in this orange yellow color, these are the final output or classification. So it means that let's say I want to predict the temperature of tomorrow. So and the temperature can be dependent on climate, humidity, wind and other aspects. So these blue color can have those wind, climate and other aspects, and these yellow color nodes will be having the final temperature value. Okay, or you can say you have divided the temperature in bins, high, medium and low. So these leaf nodes will be the value of high, medium and low. So in this way we will be when we are going to construct this decision tree, so first thing we need to have that in supervised approach we have input and output, that is x and y. So this y values will be treated as leaf nodes. So this is fixed. There is no question about it. Secondly, we have to decide now how we should be splitting this x values. It means this x has multiple features. So how you are going to split it, and the most important feature will be catered as the root node. So you have to decide which values to be taken off. So this is the major question, and the main algorithmic part of decision tree lies for this splitting. So how this decision tree work, as we have discussed also till now. So it is going to do, it is going to partition your data recursively. Okay, so let's say you have some multiple features or multiple values. So what I have said to you, let's say the feature is, let's say climate. Climate has three values: hot, cold and you can say rainy. Okay, so we because they are treating these values if it is in the form of some numbers, so that's why they are saying ki if feature value is equal to hot, so it is true or false. If it is true, there is some condition. Okay, there is some label. If it is false, it will check for the next condition. So if the feature, if it is not hot, then it check for the cold. Ki if the feature value is cold, okay, then the result will be lying here. If it is not cold, then it will be trying for the third condition as well. So it means that iteratively we can use these feature values in the decision tree. So because in algorithm it is very this splitting, recursive splitting is given you for the algorithmic purpose, but as a human you can understand that we will be having three branches here. So this is your climate and three branches will be hot, cold and rainy. And if the climate is hot, we will be going to take some decision. If the climate is cold, we are going to take some decision. If the climate is rainy, we are going to take some decision. Okay, so this is going on till we get our final answers. So maybe some feature value is compared, and in at this node some another feature is going to be compared. At third node maybe some another feature is going to be compared. Okay, so first thing is question arises how to split, how to choose this feature. So the splitting criteria are based on some aspects. So those aspects can be named as Gini index, entropy and variance reduction. So we are going to majorly discuss about Gini index and entropy. So what are these, how to formulate these, we will be seeing in the next slides as well. So presently you can have an idea that there are 2 3 different types of criteria in which we can choose the most important features, or the splitting criteria. So these can be named as Gini index or entropy. So till the we are achieving the impurity, it means if the conditions are impure, we are going to further increase the depth of the tree. And when we achieve the purity, or we have some stopping condition, we will stop. So it means that when we have properly regions defined, we can stop it, or we can stop in between also when we see that your tree is going too much in depth, because it will increase the overfit, it will increase the variance and will lead to overfitting. So that's why how to solve this condition, how to see this condition, we are going to study about that in the further detail. So now this is splitting criteria. So here one example is given to you. For example, at root node, you can see one attribute age is there. Okay, now it is splitted into 3 parts. So maybe just see this, observe this. If age is maybe the age is in the form of labels, okay, low, medium and high. This is your low age, this is medium age, this is high age. Okay, so then it will be very clear. But how they are going to do, because age is a continuous number, we can bin them in some values. So they have been bin them as less than 18, between 18 to 30, and greater than 30. So it means that we can use some binning criteria as well in decision trees if we see some group or some similar characteristics are observed for some set of values. So how to observe that? This is somehow based on algorithms as well. Or you can say that when we will be studying about this Gini index or something, we will be having an idea that how to split, how to make cut at which point. Okay, so till now you can see that this age attribute has 3 you can splits. You can say the splits, this is less than 18, between 18 to 30, and greater than 30. Now if the age is less than 18, then another attribute comes into picture, weight. So if weight is less than 60 or greater than 60, if it is less than 60, then we have low risk, and greater than 60, it has high risk. So it means that these are like if else condition. Because prior to the machine learning, when we are introducing these algorithms, we have simple rules to follow. Okay, so if you are going to make decision as a human, if I ask you, you have some if and else condition. So for example, if I say ki you have an opportunity to let's say you got a job offer, that job offer is has a mandate condition that you have to visit the office in Delhi. Okay, now you have multiple conditions in the mind ki if I am getting only this job offer or not, may I, it may be that some other else company is also giving you some good offer. So you, when you are going to make your decision in your daily life, you go by this if else condition many times. So in the similar way, this decision tree is also based on this if and else condition. So if the age of the person is less than 18 and the weight of the first person is greater than 60, then it has high risk of this heart attack. Okay, so similarly other criterias are also built up in this decision tree. So as I told you, the splitting criteria can be based on Gini index or entropy. Third criteria that they have created it for regression trees especially, that is mean square error. So basically we can say that if we have 3 values, let's say we have age and we have 3 value, low, medium and high. So what we will do, we will create a split. We will calculate the mean square error using this split, only 2 splits. Then we will calculate the mean square error using this split, and then we will calculate the mean square error using these 2 splits. So the lower the mean square error is, we will choose the split. It goes round like that, because we don't have infinite number of attributes in this type of decision tree data set. Okay, and this Gini index and entropy are used in particular type of algorithms that lead to decision trees. So there are some algorithms specific. Decision tree is a main branch of algorithm, but inside decision tree there are multiple ways. So first is this cart, that is called as classification and regression tree. This is id3 something iterative something d, I don't know, I don't remember right now. And c4.5 is also an algorithm. So in these two algorithm, the basis of the splitting is entropy, and in cart the basis of the splitting is Gini index. Even when you will see the formulation of Gini index and entropy, it is somehow similar. You can see it's just that there are two criterias, you can see like that. Okay, so let's discuss about the some the characteristics, then we will go deeper details of this splitting and some numericals as well. So basically the main advantage of decision tree is these are easy to interpret. So this term I am highlighting here because at present this interpretation is a very important tool in machine learning. Okay, we have a concept of, maybe some of you have heard about it, explainable AI, जिसको हम XAI भी बोल रहे हैं. Okay, so what explainable AI is, highly at present the neural networks are highly used in for artificial intelligence algorithm. Okay, we are not using these simple type of these decision trees or these uh, k nearest neighbor or these SVMs. These are always there for us, but the high means at present majority of the communities are shifting towards this deep learning or neural networks. And the basic disadvantage of neural network is, as you have seen in the last lecture also, because in neural networks multiple nodes are there, and these nodes can be increasing or decreasing based on the user input. Okay, and these weights, it's easy to say that we have a fully connected layer, some weights are given to it, but these weights are not explainable. It's more like a black box. Okay, so we don't care about the weights, what the weights are, we just care about what our output is. So initially this neural network was very flourished because their output is so much efficient. But now the question arises, especially this question arises from the medical terms or in healthcare, why your algorithm or why your model is giving me the output for disease X, not for Y. Okay, so when this question arises, the neural network fails to answer. I don't know, because your training is doing something and your weights are trained and I can't answer you for this question. So this explainability concept comes into picture, that if we can describe that these features from the neural network layers are so much important, or this layer is so much important, then we can have an explanation or reason why the model is performing for this input like that. Okay, so this is a now a subject, a course of explainable AI at present. And decision tree has this power that they can interpret very efficiently, as you can see from here, right? So you can have the if else rule, and you can have an idea that if your this branch is chosen, this low risk is chosen, you know why this low risk is chosen, because the age of the person is like that, whether he is a smoker or not, you are checking it. That's why you come to this decision. Okay, so that's why the major advantage of decision tree is their interpretability. Secondly, it can handle both numerical and categorical data. This is the additional advantage, I would say, because at present neural network can also do that. Okay, so it's not like a big deal. Second is, requires minimal data preparation, because in your Excel files or CSV files, if your data is prepared, you don't have to do much. You have to just put a algorithm of decision tree and put it there, it will give you a good results. But along with that, there will be some limitations or disadvantages. So first thing is, if your data set is too small, then it can overfit. Because just think about it, as a human, if I give you some 2-3 conditions out of your environment, you will have some idea ki if I am going in the market, I should go in this direction. If I am going to this market, I will going to be in this direction. You are making your mind overfit, right? Ki if the condition is meeting like this, then only I will answer like that. Maybe some of the situations in the real world may change, and if those situations are not included in your data set, then obviously your decision tree will overfit. So there is a problem with small data set, first thing. Second thing, because it is highly dependent on the data set, and if you change single row, it may change the sequence ordering of the splits or the features in the decision tree nodes. So that's why it is also sensitive to noisy data. So increasing, decreasing any row will affect the decision tree aggressively. Okay. Third thing is it is biased towards the dominant classes. Obviously, because you will see this Gini index and this entropy are the concept that are based on probabilities. So if you have some dominant classes, your tree will be biased towards that. So it means that decision trees are good to go for those problems where first your data is completely structured. Okay, you can't use decision tree for images, obviously. So if your data is completely structured, plus you have good variety of data as well, and it is equally divided in multiple classes. It's not like that it is dominant towards one class. If you have these conditions met, then it is easy to create a decision tree rather go for other complex algorithms in machine learning. So, and this decision tree is also non-linear. You don't need any activation functions or so. The structure of the tree is non-linear, and you can have those non-linearity in these trees without any much calculation or computations. So that's why at that time decision, when it comes, it was a very good tool to go, because at that time the data was not much higher as we are having the data right now in our environment. And secondly, it does not require too much calculations or something, so it's easy to go, it is good to interpret it, it is easy to make understand the audience that why we are creating these decisions. So basically, if you think about, whenever a researcher or scientist creates an algorithm, it's not for their own purpose, it's for the society, right? And we only work on the back end in the society. So there are some startups, there are some companies who are interacting with the actual users who will use this algorithm. So to make understand your technology, it is important that they should be you should be able to reply, or you should be able to convince them on the basis of reasonability, because they don't know much technicalities, they know the environmental true knowledge, the life knowledge. So if you are able to convince them, then good to go. So that's why at that time decision tree was very famous. Okay, now another problem with decision tree is this, its depth. So if I have, let's say, 10,000 rows, okay, so to analyze that data for 10,000 rows and creating a tree, maybe we have 30 columns. So it may be a very huge burden to create trees in depth, because just think about it. Can you imagine a simple binary tree in which each node, okay, just let me know what is binary tree, anyone?
Binary tree is one which has two branches, ma'am.
Two branches, okay,
Either
just
yes or no,
yes, just think about this. If you have a binary
true or
tree,
false.
yes, you can say there are only two branches, okay, strict binary tree I'm talking about. So just think about is one root node, it has two child nodes, okay, this only two. Now these child nodes also have two, again another child nodes, okay. So in this way, when you increase the height, can you imagine how many nodes are increasing per level? Okay, and here we are not saying these trees are binary. So to remove this redundancy, to remove this strictness, we need some pruning techniques. Pruning means where to stop. So we have to, let's say we have a full fledged tree with a depth of, let's say, 15 levels. Okay, so at which level you want to prune your tree, that after that level you will have only leaf nodes. So that's why these pruning comes into picture, because without pruning, if you are going to make the complete tree, it will obviously overfit on your data. because it has seen some portion of the data and it will try to reduce the error as much as possible. And it can do by creating multiple branches, by creating multiple rules. It's not an easy, it's not a difficult task. हम क्या करते हैं, what we do, let's say we have a lot of conditions, so what we will do, we will create one condition for each data. That can be the easiest way to do, right? If this, our data is this, if this, our data, our answer is this. We can create multiple conditions. We will not remember it obviously, but it is a very noisy way to create those splits or conditions. So that's why pruning comes into picture. So pruning can be done pre or post. Yes, someone wants to ask something.
Limitation of decision tree.
Limitation of decision tree.
Overfitting.
Overfit. Hello.
Can you hear me?
Yes, now it is clear.
Help with the overfitting of small data sets,
Okay.
which was one of the limitations in the automated
Yes.
Yes.
So you want me to explain this point?
Or based on pruning. Would pruning help, or is there another way of making sure it doesn't happen?
Okay. Look, I'm talking about small data set. Small data set means we have a limited, maybe you can say the variance is not there, some biased are there. Okay, small data set mein obviously you will not have variance, or you can say if you have variance and means more variance and less bias also, it means some of the samples are just jumbled. Okay, for example, let's say we have 5 rows, 1 2 3 4 5, or these 5 rows are belonging to different classes. Okay, so what the decision tree will do, it will be trying to create the rules for each of the row such that after final creation of this tree, the model will not give you some error. Okay, because this data is very small and it is trying to cover all the rows with less error, so that's why it will not be able to give you good results or generalization over the testing data. So that's why we are saying it is overfitting. Overfitting means in training you will get good accuracy, but at the time of testing you will not get good accuracy. Problem is of generalization. So that was the limitation, and that will happen even small data set. I'm trying to say, because if you use a small data set on neural networks also, they will try to generalize things, because the way of mechanism that the weights are training are not dependent on rows, right? These decision trees are specifically dependent on the features that are given to you. It is not converting your features in another aspect, it is just taking the feature value as it is as it is given to you. So this is the limitation of decision tree. The problem of decision tree of overfitting is also associated with its depth, because as many rows you are inserting in your data, and this tree has a property that it should reduce the error or increase the accuracy, so it will try to fit each and every row in some particular leaf node so that your error will be less. So this can be achieved if it creates multiple types of split at every node. So it means that, let's say you have this split at feature 1. Okay, this feature 1 is splitting into 2, let's say this and this. Okay, here there are maybe 99% samples are there, only 1% samples are lying here, right? So it means that it will create a branch that will give you a more depth, but just because of this 1% type of data, so it is creating overfitting as well. So here this limitation is related to small data sets which cannot be which cannot be catered. So we have to increase the size of data set, it's more like that. Here we can use this for the depth, we can use pruning, that we can prune at this level. So I will not split at this end. After this F1 I will directly use the leaf node. So maybe 1% of the samples will be giving me the error. It's okay, no problem. But maybe this 1% samples which I am going to split further and further and further, it can increase the overfitting for my testing set. So this is why pruning techniques are coming into picture. Is that clear?
Yes, ma'am.
Okay. So pruning can be done in both ways, pre-pruning or post-pruning. In fact, how many of you know this term dropout in neural networks? Just raise your hand. Would pruning not cause
Don't know,
overfitting?
ma'am.
Okay, how
Hearing
many
for the
of
first
you?
time.
Okay, how many of you know? No one. Okay. So basically, अच्छा आपने क्या लिखा? Would pruning not cause overfitting? It can cause overfitting, but we are going to use it intelligently. Okay. So obviously, if you are going to use pruning at the first or second level, then obviously it will not going to give you the good answers. Acha, I was talking about dropout. Okay. So in the last class, we have seen in the neural networks, these are the two layers. Let us suppose. So what I did say to you, um, just connect all the neurons with every neuron in the next layer, which we call it as fully connected layer. No problem. This is fully connected. It means it has three values. It has three values. So we will be having 3 cross 3 connections. No problem. But in reality, when we have analyzed these weights, some of the weights are so much low that they would not contribute in learning. Or if we can remove them, then it will not affect our network. So what we do is, this is also causing overfitting. So that's why there is a concept of dropout there. So what we do, we define a probability in dropout. Let's say the probability is 0.4. So it means that with a probability of 0.4, I can drop this weight if required. Okay, so if you have applied this dropout, so with this probability, some of the weights will drop out. It means the connection will not be completed. So we are going to say that now our network is not fully connected. Why we are doing so? First, it is reducing some of the parameters for you. Secondly, it is reducing overfitting. So in the similar way, we are using pruning techniques in decision tree. So for dropout, as we use the neural network in a common way, we just apply dropout at some levels with some probability. These are the hyperparameters. We tune it, means we run the code, we set the maybe dropout probability 0.4, we get some answer. We change this probability 0.3, we get some answer. We change this probability 0.5, we get some answer. It check which level is giving us the good outcome. So it's not like that we have to much focus upon on this dropout, but there are some studies specifically for this dropout, because some intelligent thing is algorithm is placed in this dropout function. Initially we were doing it randomly, but after some analysis, what dropout is doing, dropout is dropping those values which are minimal. Okay, so it's not like that it will drop out the major weights. No, so it will be dropping out those weights which are very minimal, which will not contribute in your learning. In the similar way, we are going to use pruning. So pre-pruning means while making the tree, just stop when the tree growth reaches at some particular depth. So it means that you define that depth. So when you use some function in Python, you define a depth of maybe 3. So it is pruned at level 3. If you are defining the depth at 5, it will be pruned at depth 5. So it means that you are predefining it or using some intelligence to stop when some condition is meeting. So that condition will be defined by the user or developer, I should say. Second is post pruning. Post pruning means you just have full growth tree and now remove the weak branches which are showing you some weak branches or some areas where you can say you can just like I have given you an example. By creating this data, I am creating a full tree, and this is having 90% data, and this is 99% data, and here it is 1%. So after creating this tree, I get this answer. So if I get this answer, I will prune it here. So either you are using pre-pruning or post-pruning. There are multiple techniques in this pruning area. Okay. So now there are multiple algorithms: ID3, C4.5, CART, and random forest. Presently, in your syllabus or in the lectures that I found on from Balaraman sir, they have not discussed in detail about these algorithms. Okay, but they have discussed how splitting is done in detail. So I am going to use that part only. So if you know how the splitting is going to be done, you can easily go through these algorithms as well. But let me very frankly say to you, if you have a smallest decision tree with 3 columns, okay, it will be very difficult for the calculation part, because it is, first thing, it is iterative. Secondly, from means when we are going to solve this, you can see that it is going to be solved for each and every feature, then it will sort that which feature is most important. So it's a hectic thing. For computer it is easy because it can iterate or recursively call many functions in small time, but as pen and paper work, it is not difficult, I should say, it is time consuming, I would say. So if you are in your good mind, happy mood, and you have a big problem to solve with consciousness, you can sit and solve the full questions, maybe take some time to go for it. Okay. So, and a last method is this random forest in some ensemble method. This is very important. And at present, even if someone is working in machine learning, you will find this random forest ensemble method has achieved a huge accuracy in terms of other algorithms in machine learning particularly. So if I just remove this deep learning part, random forest is one of the most important algorithm of your machine learning. Okay, many times it gives the better answers than other one. And secondly, this ensemble thing, we are, I think, yes, we have this topic in our later slides as well, later lectures as well, but I'll let you know what are these ensemble methods today in some uh, as an introductory topic. Okay. So now we have some idea of decision tree, how they are working, what are its advantages, what are its disadvantages. So first have a comparison with other ML models. So what we have learned in these sessions, the major algorithms were SVM and neural networks. So first thing that I already told you is interpretability. So decision tree is highly interpretable, SVM is medium, and neural networks are low. Neural networks you don't know anything about. You just know there are some weights, those weights, how they are trained, they are just performing some optimization algorithm. If they are changing from 0.1 to 0.001, you don't have an effect. It is changing, okay, let me see the answer. But in SVM, yes, because you can see some boundaries are creating, you can have an idea that if I change the k parameter with some value, how much change in the boundary I will have. So somehow it is somehow interpretable, but decision trees are completely interpretable. Okay. Second is computation time. So computation time means, this is, I am talking about testing, not training. So it means that if you have saved one model of neural network, of SVM or decision tree, so neural networks will take moderate amount of time, because once you train your system, you will have weights. What you have to do, as many number of neurons or layers are there, just take the input, multiply or add those, or apply the activation function, and you just have to go for the forward pass. So here this time takes for the forward pass. So if the number of neurons are high, number of layers are high, number of functions are too many, so it means that some time will be taken, but it will be considerable, no problem. SVMs are completely slow. Why they are slow? Because as you have seen, if you are going to have some data, you have some training data, and basically if you have some that hyperplane line or so you have to calculate those alphas. Okay, so those alphas creation, it takes some time. Secondly, this decision tree, what you have to do, you don't have to do anything because the branches are made, some if else rules are made. So it's more like that. Those if conditions will be tested and it will be done in a less time. So that's why these are fast. Third is handling missing data. So handling missing data, just what we can say is, if you, let's say, because this decision tree are specifically working on CSV files, okay, so it means it is highly structured. SVM and neural networks are working on any form of data. So if in a CSV file some value is missing, okay, so we should have some mechanism that can handle it. Otherwise, SVM and neural network will not work on that. But in decision tree, maybe some missing values will not get affected in the branches. For example, let's say in this diagram, you can say this one. Just think about this. If the age of a person is 18 to 30, it is directly giving you a leaf node. It means, let's say, if a age of a person is 19 and its weight is not given, it is missing, then it will not get affected here. So it can somehow handle this information. Okay, if it is not present, okay, we will not create the rule for it. It's more like that. So that's why I am saying it is more related to a human psychology. So for a human, if something is not given to them, they are saying that कि okay ठीक है, we will not create rules for it, जितना दिया उससे काम चला लेंगे हम. So it's more like that. Okay. So this is your decision tree versus other algorithms. Now, specifically in starting, when decision tree comes, it is very evident that because there are some nodes, some leaf nodes, so it is easy to prepare a decision tree for classification problems. Because you have predefined classes, you have predefined labels, it will not have a problem. Problem is how you will create a decision tree for regression. So here the key idea is partitioning the input space into regions, because let's say if I have to predict the temperature value, it can be 49, it can be 49.01, it can be 49.9, it can be 49.099. Okay, so can you put them in the same bin, or how you are going to say that this leaf node will give you this value? Okay, so for that what they are saying, just partition the input space into region. तो जो भी आपकी input space है, that decision nodes and the root nodes, divided into some regions. So when we are going to divide them into regions, we can take the average out of it and put the values there. So it's more like that, like this. So what they are doing is, here they are dividing the data into smaller regions. So, and assigning a prediction to each region, maybe a constant linear model. So it means that if here it is, for example, look, the first root node is outlook. If the outlook has a value sunny and the weather is windy, true, the answer is 26.5. Okay, so this 26.5 is not a single number, it's a value coming out of a bin. So here what they have done, if your conditions are met like this, so maybe multiple values will be there in the target. So either take the average of it. Okay, so simple way is take the average of it. Second way is, till this windy, create a decision tree, and after that train a separate linear model for each bin. So for the leaf nodes, where you are getting these leaf nodes, so these are the different regions. Okay, so these different regions can be trained separately as a linear model or linear classification, linear regression that we have studied, or in the you can say a naive way, what we can do is we can just take the average and show it here. So it will, if you are taking an average, always it will show that average value. So obviously if it is showing you average, it is not giving you good results. So that's why a simple change can be applied there, ki for each of these regions we can apply separate linear models. So for these values we can apply some, you know, some linear model and then go for that. So this is how regression trees work. Okay, so they are also saying piecewise constant approximation, that each region has constant predicted value, mean of the data. So you can have an illustration with the data set. That is not here. Okay, this one. Printed किया. I had pasted some data set maybe. Okay, by mistake I think I have not, but I will paste some illustration with the data set as well. So here it means that ki for each type of regions you are going to have a piecewise constant approximation, that can be a simple mean or that can be a linear approximation as well. Okay, so but ultimately you will have one answer. Obviously the leaf node is static. Okay, so instead of a constant, each region can have their linear function. It is more complex but can capture trends within the regions. It's okay. So another way is you can have some optimal partition using greedy approach. So what the greedy approach is, we can select the best feature, we can split the point by minimizing the error, and then recursively apply the same process. How you can do that? Just see this example, this one. So here you can see that there are two attributes. This is X and this is Y. Okay. So first thing is we have to just find a point where we can make a split into this and this. Okay. So what they are saying that suppose we try splitting at 1350 at this point. Okay, if we are going to split at this point, it is in the middle, but because when we don't know anything, we go by some default values. So the default value says that if you have no idea where to start, either start random or you can start at the middle point. Okay, so this is more like a middle point, that's why we are splitting at this stage. So it's more like that ki this will be one bin, this will be bin 2. Okay, so here you can see the values are 120, 150, 180 and 200. Okay, so the mean of these values are, it is written here, 162.5. Okay, similarly we can take an average of these values. This is 292.5. Now what we can do is, because by regression algorithm, the final leaf node will be considered as this 162 for all these values. Okay, and the leaf node will be considered as 292.5 for these values. So you can have a mean square error from all these true values, right? So we choose a split where this mean square error can be minimized. So how to shift further above and below, this is how a greedy algorithms work. So similar, what we do generally in let's say ki these are 1 2 3 4 5 6 7 8, 8 values are there, it means we will make 7 partitions. So for all those 7 partition we will calculate this mean square value and then check that which partition is going to be better for our algorithm. So this is how you are going to split it for this regression algorithm. And if it is for classification algorithm, you can check simply accuracy here. So it is easy to do. Generally we don't use regression algorithms with decision tree, but on the sake of making the decision tree, we can say that yes, you can apply decision trees on these regression type of problems, but it is not very fruitful. So we generally go for the traditional approaches that we have studied for regression algorithm rather than decision tree. But yes, because when it was created, it was asked that whether you can use it. Yes, we can use it in some way, because you have to, as you have learned about logistic regression as well, it's a modulation from linear regression, right? So the main concept of regression and classification is same. It's just that we have multiple values at the end which cannot be handled with decision tree. But if you are okay with this average type of value or some linear function defined on that, then you can go for this decision trees as well. But generally we use decision tree for classification purposes. So here they have created these 1, 2, 3, 4, 5, 6, 7, 8 partition, but I would say ki you will have to have some only 7 partitions. This cannot be counted. So basically we find that the minimum error at some space, so wherever the error will be minimum, you can have that split in your end. Okay, so this graph is shown is for the split that is given here at 1350. So if we are going to make this split at 1350, then it will be showing like this. So these are the average values. Okay. So now disadvantage we have already done. Now early stopping and pruning, this is already we have discussed. इसमें ऐसा कुछ नहीं है. Okay. Okay, so here some strategies are given to you how you can apply pruning techniques. Okay, so basically, you know what is overfitting. Overfitting by definition, it means that there are too much variance in your data. How you can diagnose overfitting? The major rule is the training accuracies are very good, but testing accuracies are very bad. So it means that there is a problem with generalization. So we can say that trees can become too complex and fitting noise instead of patterns. So this can be an understanding that if you are overfitting, it means you try to reduce error what you are seeing. So what you are seeing, you are just keeping that in a mind as a rule. You are not finding the patterns out of it. You are not able to say that this is not in a pattern, this is an exception. You should be knowing that this thing is not included in your data distribution. It is somehow unfit for your data distribution, which we are not able to get if we are overfitting. So it can lead to high variance or poor generalization, obviously. So solution is, as we have discussed, we can control the tree depth by stopping or pruning. So there are some strategies or stopping criteria. It is written here कि we can stop the tree growth before it fully fits the training data. So it means early stopping. Where we can find that early stopping? So first thing is minimum samples per leaf. So let's say if you are defining some rules and let's say this is your feature, and at this feature you are going to split. For these split you can have, as I have told you, this is 99% and this is 1%. Now you have to stop, because at this leaf the number of samples are not meeting the criteria. So it should have some minimum number of samples, otherwise it will lead to some extra overburden. So first we can define this criteria that for a leaf, if number of samples are, let's say minimum some number of samples are 10, so it should obviously have at least 10 samples in your data set to satisfy this condition. If it is not doing, then you can merge them and you can prune it, stop it. Okay. Second is maximum depth. This also we have already discussed, that you just apply ki, let's say we have a depth of 7. So whether your tree is going up to 1000 depth or 10,000 depth, it doesn't matter to you. After 7 it will stop. Okay. Last is minimum information gain. So this information gain thing is related to entropy, and we are going to discuss this. So what information gain is, you can see that at this feature, if information gain reaches at this position, then we can stop it, because at the first root node the information gain is higher, then it reduce. So till when you wanted this reduction, you can apply this condition also. So these are some intelligent ways that are defined on your already predefined libraries, that at this position we can stop increasing the depth of the tree. So this is how early stopping work. So post pruning, it's quite easy because you have a full grown tree and you can apply these techniques as well after that also. So you can simply remove unnecessary nodes where you are seeing that the data is not being fitted there. Pre pruning, we have seen these strategies. Okay, so I am not going to. So you can have this example here. So this is the left hand side. It is using a scikit-learn library in Python, and when the nodes properly given to them without any restrictions, then you can see the depth is 7 and nodes are 41. And when the depth is defined as 3, then it is creating a beautiful tree which can be easily interpretable and seen, right? So this is how at each stage either you can give the maximum depth. So here, in this way you can apply this pruning, okay, because decision trees are not used nowadays much in much detail, so that's why much of the processes are not in detail as well. And secondly, it can be um, easily conveyed if some data specific, you can say, or in other words I would say, at present we don't have data that can handle with this decision tree. Maybe in some finance or some chart sheets were there are there, but at present we are generally working on text, language, audio, videos, which don't require these much type of processing. So it's more like one of the concept. If you want to use them in some later stages, then you should know about these things. Otherwise these things are actually very complicated to run. Okay. So this is what you can do. Basically in these decision trees, what I personally find is quite interesting or to learn here is this splitting thing, because this splitting is based on some probabilistic measures, or you can say that we can learn about how to represent data and how to choose which features are important. So this is good for the feature selection process as well, or for defining the data in respect of features. Okay. So the major concept of decision tree is still going on in your textbooks is just because of this splitting criterias, because we don't literally learn about these criterias in other algorithms. So that's why this is a major concept to learn. Otherwise these are quite not useful for many data types. Okay, so first let us define some probabilistic functions, that how we are going to define it. So let's say we have some region. Okay, region means this is a leaf node, so every leaf node is defining some region. So let's say uh, coming to this leaf node, you are using some criteria, you are using some conditions. So let's say feature 1 value is this, then feature 2 value is this, and you then reach this leaf node. So basically the number of samples that are defining these things can be following this or cannot be following this. Means maybe some samples are misclassified using this rule. It can also happen. So that's why there is a need to define the probability in a region. So the region is defined as M and the class is defined as K. So in region M, what is the probability of K? So it's a simple process that in region M, how many total samples are there, out of which how many are belonging to this class K. So let's say in this region, let's say there are total 100 samples. in your data set. This is total number of samples. In this region M1, let's say there are only 22 samples. Out of which this 22 samples, let's say there are k classes, that means let's say 1, 2 and 3. There are 3 classes. So for class K1, there are only 5 samples. So the probability will be 5 by 22. It's simple. It is just defining the class probabilities based on regions. That's it. It's a simple concept of probability in a region. Okay, so now you are going to use this type of probabilistic term again in this PPT. So if this is a so this 5 by 22 are the particularly you can say this is the 5 by 22 is the probability that these number of this is the probability of class K. So not having of class K is obviously 1 minus P, right? So it is more like that. So why they are terming it as misclassification? So let's say this leaf node has the class K is equal to 3. Okay, so for K is equal to 3, out of 22 there are maybe 15 samples. So it means that 15 out of 22 samples are belonging to this class K is equal to 3 and they are correctly classified. And 1 minus 15 by 22 are misclassified. So it can happen when you are pruning your data, right? Maybe if you are not defining your pruning, it can further increase the depth or make the rules and make the system overfitted. But because you have used some predefined pruning techniques, or maybe because of some the properties of your data, your level is defined as the leaf node as K is equal to 3, out of which this only 15 out of 22 samples are correctly classified. So rest are misclassification error. So this is how you can define this misclassification error and simple classification accuracy. Okay, so there is one problem also here. Let's say a model classifies 100 samples and then the confusion matrix is given you like this. Okay, so this is your actual and this is your predicted. So you have to compute the classification error rate. So basically if I am saying this is my actual labels, this is my predicted labels, and you have given a matrix in this form, it means that I am saying if your true label is 0 and your predicted label is 0, there are 40 samples. If your true label is 1 and your predicted label is 1, there are 35 samples. So these many samples are correctly classified. Okay, so there are total number of samples which are correctly classified will be 40 plus 35. Okay, so the remaining samples are incorrectly classified. So this simple reduction is represented in a matrix which is called as confusion matrix. So the diagonal elements are representing your true values. It means what has been in the given condition, it is predicted as it is, means the error is 0. And rest of the matrix means here these values are for the error value. So it means that if the question is there to calculate the classification error rate, then you have to add these two values 15 plus 10. So these many samples are incorrectly classified. So it means there are 25 misclassified samples and total number of samples are addition of all these 4. Okay, so this is how if some matrix is given to you and if someone asks you what is the error rate or what is the simple accuracy rate, you can simply get it from this confusion matrix. So can you able to answer the error rate and accuracy rate if some confusion matrix is given to you, yes or no?
Yes.
Okay, so let's say if I am saying here there are 2 classes only, so let me give you 3 classes. So let's say there are three classes, 0, 1 and 2. Here it is 0, 1 and 2. So the number of samples are written as 20, 40, 40, 10, 80, 10, 20, 20, 25. So can you give me, this is not, so now can you give me what is the error rate for this matrix?
Take the total number and all these minus the total cent 0,01,1.
ऐड करके बता दो मुझे, कैलकुलेटर तो है आप लोग के पास. Okay, let's do the opposite thing. If you can give me the accuracy also. Zero point 452. Someone has written 0.452, 140 by 100, 140 by 265, 140 by 265, 140 by 265. अच्छा 100 तो नहीं होगा, because just take the sum of all these values. So total number samples will be all these values. So 20 plus 10 plus 20, 50. This is 50, 100. This is 200, 240, 50, 60. 265 are total samples. Okay. So how many of them are misclassified? These are misclassified. This, this one. Okay. 80, 90, 100 and 120. 140. So this is the classification error rate, you can say. So it means that if some matrix is given to you, this is called a confusion matrix, in which one of the either rows or column represent actual value or predicted value. So we can say that the principal diagonal is the is having the numbers which is giving you accuracy, and rest of the other numbers are giving you errors. Okay, so misclassification. So if this matrix will be given to you, now you are able to solve it for classification error rate or classification accuracy rate. Okay, and maybe in some class we will discuss more functionalities over this matrix, but at present this is only we are going to discuss. Okay, so this is called accuracy or error. Okay, misclassification or classification, you can say. Now we will be using the other splitting criteria. So basically we are going to discuss about two important criterias. First is Gini index and second is entropy. So Gini index means it is measuring impurity. So just think about this. So these two criterias you will see in a different formulation, but what they mean is somehow same. Okay, so ultimately it's more like that ki they are pointing towards a similar goal or similar thing, but written in two languages, I can say like that. So just let me know one thing. Let's say if there is just from your perspective, just let me know, there are some values of probability. Okay, so if probability is 0.2, if probability is 0.5, if probability is 0 भी ले लेते हैं चलो, if probability is 0.8 and if probability is 1. Okay, what do you think? These are the probability value. Okay, what do you think, which probability values are giving you the maximum information? I'm asking you these are the probability. Let's say I am asking you the probability of having rain tomorrow. So these are the probabilistic value. The probability can be 0, the probability can be 0.2, the probability can be 0.5, the probability can be 0.8, and probability can be 1. So which of these value is giving you the maximum information?
One.
One.
Okay. 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 Many of you have written 1, or I can say 0 also, right?
Zero also. Yeah.
Right.
Because information is inverse of the probability.
No, I would just
Sorry, sorry. Yeah, yeah.
huh.
Giving information is one only. One and zero only.
Yeah, you can say
Z-
from
z-
your perspective. Why I have
Zero means
asked
no
you?
rain. One means exactly there is going to be rain. Remaining all not giving any clear cut information.
Right. So, as a perspective that you are having as a human, because you say that from 0 and 1 event, we are sure about some event, that's why they are giving us the more information. Okay. In information theory, this is discarded. So, in information theory, we say that more the randomness is, more the information lies. Okay. Why?
Yes.
Just think about this. I have given you these probabilistic value just randomly. I have thrown you. Okay, maybe this one is the noisy parameter. If I tell you ki the probability of rain tomorrow is having 1, and you will say, okay, yes, this is the most important information that I have get, and it is true. Okay, tomorrow will be raining, and tomorrow maybe I have given you some misinformation, some wrong information, some noisy information, and you are just stuck into that. So information theory say that because the more the randomness will be, the more you are having the information. So it means that the maximum information lies where the probability is 0.5, the maximum randomness. Okay, so the main goal of asking me this question is that you will not confuse. Whenever we are defining information, we will be defining more randomness. It means that this variable has this randomness that we don't know the output will be like that or not, right? So the more the randomness will be, the more the information will that attribute will hold. So if some attribute has no information, it means that, let's say, some attribute, let's say there is a climate and the attribute is all rainy, 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 then you don't have to process it. Okay, if it is all rainy, don't have to worry about it. It's more like, if I ask you, let's say if I ask you a question that I have to divide your class into classes. I have a tournament to go for cricket. I want to find out that which students can be in the team, part of the team, and some students which should not be the part of the team, right? So thing is, I am strictly saying the team that I am going to make is men's team. So obviously, if wherever the gender is female, I don't need them, right? So it means that the gender is not playing any role because all will be men. So this will not play any role. It will not give you any information regarding that decision. So that's why in information theory, we think in another perspective, where we associate the most information with the more randomness. It means where you are getting this pure events, 1 0 are pure events, so it will not have any information. Okay, is that clear? Is this thing clear to you?
Yes, ma'am.
Okay, okay, done. So now talking about this Gini index. So Gini index, what it says that it measures impurity. So how much impurity is there? It means that if your probability is 1, it is pure, completely pure. There is no impurity there. So Gini index term this randomness as impure and pure, and information gain or entropy works in another aspect which I told you, right? So if all samples in a region belongs to one class, the Gini index will be 0. 0 means pure. Okay, so the formula for Gini index is given like this. So it is more like the summation over that class, summation of all classes, the success probability multiplied by the failure probability. So how you are going to calculate this, we will be seeing one example. So important is remember this formula. So it is the product of two probabilities, success into failure, and the summation over all classes. Now, second is this information gain or cross entropy. Okay, so the entropy has this formula H is equal to minus of summation of P log P. So here also think about this. Here also we are having a product. Here also we are having a product. We are having a product of two probabilities. Here also there is a product of two probabilities. Summation is there. Summation is there. Here just a minus term is there because of log. It's just that because of log it is minus coming out here. Otherwise, similarly, the formulation of these two formulas are most similar, just that we are depicting in some different ways. So either you are using Gini index or you are using this cross entropy or information gain, both will work. But question में जो दिया होगा, you have to use that formula. Okay, so now just see how to calculate this entropy and information gain. Okay, so let's have some problem. We have this data set of 3 classes. Okay, in which class A has 40 samples, class B has 30 samples, class C has 30 samples. This means total हो गया आपका 100. Okay, now compute the entropy. Now formula is given to you, just calculate the entropy and let me know what will be the value. Here log means log 2. Log base 2. You can just write the formula as well in the chat. So the question, I am again repeating, there are 3 classes, class A, class B, class C. There are 40 samples, 30 samples, 30 samples. Total number of samples are 100. You have to compute the entropy. Entropy is written here. You can say pure or certain are the same things. Minus 0.4 log 4, 0.3 log 3, 0.3 log 3. Correct. So is this fine to you? Are you able to calculate the entropy if some problem is given to you like this? Because look, let's say if I am saying A is a data set in 3 classes, it means that it simply means this is the attribute A in which there are 100 samples. These 100 samples, out of which 40 samples are belonging to A class, 30 samples belonging to B class, and 30 sample belonging to C class. Here data set is meaning single feature. So what we are going to do, we will calculate this Gini index and cross entropy for each features present in your data set. Okay, so here I can have an idea that this will be your final entropy of this attribute 1.57. Is there any problem in this calculation, entropy calculation? Then please go ahead. Okay, done. Now let's say this is your decision tree. Okay, so just note down these values because we will be calculating the entropies and other things for this. So this is your decision tree in which
Just one question, ma'am. Is it log or natural log? LN.
it is log 2,
Log base 2.
log base 2.
Because I
It's
used a
not
scientific calculator and I got a different answer. So I asked it.
okay because in scientific calculator it is using log base E.
Okay.
or by default it can be log base 10. It is not by default log base 2. It is confirmed, but maybe ln, if there is an separate symbol of ln, then the simple log by default is set to 10 base. Okay, so this decision tree, this is your decision, we have to make the decision tree for this data. So it's a very simple type of data, okay, having only 2 classes per feature. So here also there are only 0 1, here also it is only 0 1, here also it is only 0 1. No problem for that. Okay, now we
It's
have,
a logical OR operation, correct, ma'am?
yes, I
The
have
tree
chosen,
seems to be.
yes, you can say that, but I don't think it in that way. I have just put some, means some dummy data I have taken.
Okay, okay.
So what you have to do is, first you have to calculate the very first step. When you are using entropy, calculate the entropy of this y attribute. Just let me know what is the entropy of y. A by 2. So we are going to get the values like this. Okay, so first what you have to do, you have to calculate the probability of P0 and P1. Means there are 2 classes, P0 and P1. So the probability of P0 is 1 by 4. Probability of 1 is 3 by 4. This is 1 by 4. This is 3 by 4. Just put it in the formula and you will get this value 0.811 around. Okay, is this fine? Okay, so basically this is first step when you are using entropy for your splitting. First we calculate the entropy of the final attribute. Okay, now we calculate information gain for each attribute that is remaining. It means that what we are going to do, for each attribute, let's say I have chosen this. Okay, I have chosen this for splitting. Now what will be the attribute, what will be the entropy of this whole system? So it means that information gain is nothing, it's just the entropy of y given x1, like that. Okay, so it means that, wait, see here. Okay, here you can see you have calculated the entropy of y. Okay, now what you will do, you will calculate the entropy for x1, you will calculate the entropy for x2. It's not like x1 and x2, you calculate the entropy of y given x1. Means if I have chosen x1, then what change in the entropy comes in this final attribute y. So that's why I have written here, there are two specifically two values in entropy. When y given x1 is equal to 0 and y given x1 is equal to 1. Okay, the formula is same, it's just that you will have to choose only those rows where the x1 is 0. So it means that out of first 2 rows, calculate the entropy of y. Am I able to explain this? Listen again. What I am going to do now, I have calculated the entropy of y. Entropy of y means this is the whole information of y. But now, let's say I have chosen x1. So if I choose x1, there will be splits. So splits will be based on the classes. So let's say if I choose x1 is equal to 0, what will be the entropy of y? If I choose x1 is equal to 1, what will be the entropy of y? So similarly, we will calculate the entropy of y given x1 is equal to 0 and x1 is equal to 1. So there are two calculations here. So when you choose x1 is equal to 0, only top two rows will be chosen, in which one is 0 and one is 1 in y, you can say. So it means that 0.5 probability for both the classes. If you choose x1 is equal to 1, there is only 1 in the y class. It means it is not impure, it is completely pure. It has no information. So if your x1 is 1, your y will be 1. There is nothing to explore. It's stuck, right? So here we will be creating these two groups. So just see this, and if you have any doubt, then please let me know your doubts. So is it fine that now if I give you some data, because I am going to give you some data after this, and you have to calculate what will be the entropy of y given x1 or x1 is equal to 0 or the classes जो भी हम लोग अभी use करेंगे. So is this step clear to you? Yes or no? See once again, take 2 minutes and calculate. Similarly, this calculation is given to you. Now you have to give me the same calculation for x2. एंड आफ्टर दैट यू हैव टू टेक द वेटेड ऑब्वियसली. सो वेटेड हम बाद में निकालेंगे. पहले आप मुझे ये बताइए कि इज इट क्लियर these two steps? Entropy of y.
If you won't mind, ma'am, would you please tell me the difference between step 2 and step 1? Step 3 is different. Step 2 and step 1. What are we trying to find in step 1? What are we trying to find in step 2?
The first step is you are calculating the entropy on the target value. Okay? On y. Okay. Now your task is कि which attribute to choose so that it can be placed on the root node. Okay. So there are two attributes, x1 and x2. Which attribute is important? The attribute which will be important, that after taking that attribute, the information gain should be minimum, right? It means I have taken such information at the big end so that now remaining information is less. For that information, I would choose the second attribute. Okay? Right? So for that, if I have two attributes, I have to calculate the entropy considering I am choosing x1. So this second step in which group 1 and group 2 is used, in this step I am considering I am choosing x1 for splitting.
Okay.
ठीक है? So for this splitting, I can choose the split on 0 or 1. I will have these splits, right?
Yes.
There are two classes. So it means that if I take a split on 0, there will be some entropy. If I take the split on 1, there will be some entropy. So I am calculating both the entropies separately. And after these two separations, we will combine them using weighted. This is what you do, right? So basically, here look, these are the two values, these are the two values. So for these two values, there will be the entropy from this. For these two values, the entropy from this. So there will be some entropy, let's say h1. There will be some entropy, let's say h2. Now I have to combine it, because if I am creating this x1, there will be 0, there will be 1. There will be some attribute here, correct? So till here, there is h1 entropy. Till here, it is h2 entropy. Because I have chosen the both paths. I have made the tree and I have given this 0 and 1 completely. So it means that at this stage, I have some weighted value h. Which is the combination of some h1 and h2. Getting my point? Okay. So this weighted step, how we can take that? Because there are two zeros and two one. So it means Ultimately, how much weightage you will give to H1 and H2? How many samples are of 0? How many samples are of 1? So it means that here they are equal samples, to 0.5 probability, 0.5 probability, 0.5 into H1 plus 0.5 into H2. So this is the next step that I was going to say, that this is the weighted entropy, the combination of this and this. So this and this, because it is based on this x1 value, so how many values are 0, how many values are 1? So 2 out of 4 values are 0. That's why it is 2 by 4. 2 out of 4 values are 1. It means it is 2 by 4. So this is 1, this is 0, this I have put here. So this was the next step, but I am asking you, are these two steps are clear or not? पहले तो आप ये बताइए कि are these steps clear or not? It means that in first step you will calculate the entropy of the target variable. In second step, because you want to find out which attribute is to be chosen for the split, so take first attribute, calculate the entropy within the classes. Take second attribute, calculate the entropy within the classes, okay, and choose on the basis of information gain. That's what we are going to see in the next steps. But for before that, are these steps clear or not? If entropy is 0, purity is gained. Yes, obviously. So we don't have to split that attribute जहां पर entropy 0 है. It means we achieved the purity. Okay, so basically what we are, so similarly in this way, let me just erase all this. So similarly, can you give me a value for attribute 2 also? Okay, so this is for attribute 1, x1. I am saying similarly give me value for x2. So if you choose x2, what will be the value here? What will be the value here?
Same, ma'am. Same as x1, na?
सेम एज x1. चलो, बिकॉज कुछ इस तरीके से वैल्यूज ली हुई थी. लेट से मैं यहाँ पर इसको 0 कर देती हूँ. Okay, then the value will be different. Getting my point? अगर मैंने हाँ इस वैल्यू को 0 कर दिया, then it means the value will be different.
Yes, ma'am. That should be different.
Correct. Will be
Yes,
different,
yes.
right? It should not be here because it means that for 0 0 0 you are giving two values. So it will create some noise here, but still you are getting my point, that if the values here it is 0, then it means that for 0 value you will have these combination. So it means for 0 it will be 1 by 3, for 1 it will be 2 by 3. Here it will be 1, right? So it means the entropy will be here 0, here it will be coming in some point form, because there is some randomness, okay, in 1:2. So now we will combine them. If using these parameters, so we will be going to, let's say this is A. So what I am going to say, this is 3 by 4 A plus 1 by 4 0. It will be like that. Is it clear?
Ma'am, can you explain? Ma'am, no, ma'am, can you explain x2 again?
X2. Let's say I have
Yes,
changed
yes.
this x2. Okay, initially it was 1. Initially it was written as 1. Okay, I changed this because using 1, if I say you, if you are going to use 1, you will get the same results. Correct? Yes or no? If you are using 1 here at this place.
Yes.
Correct? So what I have done, I have changed it to 0, just to give you an example. So if I am going to change it to 0, it means I am, for this case, I am choosing these 3 rows. In these 3 rows, the 0 probability will be 1 by 3. The 1 probability will be 2 by 3. Correct? And you take this combination, put this in this value. When you will putting this in value, because it is divided by 3, it will be not coming 1, it will be something 0.8 or something. It will be coming like that. Okay? Some value will be there. It will be not be 1. Getting my point? If you want to calculate it, calculate it. No worries. The formula for here will be, it will be more like 1 by 3 log 1 by 3 plus 2 by 3 log 2 by 3 minus. When you will calculate this, there will be some value in points. It will not be 1, it will not be 0.
Madam, how we are taking it is 1 by 3 and 2 by 3?
Just think about this. See here. What I want, I am saying entropy of y given x1 is equal to x2 is equal to 0. Here I am saying entropy of y given x2. I am talking about x2, right? So in x2, where x2 is equal to 0, these 3 rows are there. Here these 3 rows will be considered. Just give me the probability of 0 and 1 in these 3 rows.
1 by 3 and 2 by 3, ma'am.
So that's why I have written 1 by 3 plus 2 by 3. आपने यहाँ पर भी तो यही किया था. पहले आपने बोला था there are 2 rows, right? So if there are 2 rows, here are 2 rows. So in these 2 rows, it is 1 by 2 and 1 by 2. That's why you have written 1 by 2, 1 by 2, 1 by 2, 1 by 2.
Yes, ma'am. Clear, ma'am.
Okay. So it means that I am saying I am not having the actual value. That's why I am considering it as A. And for this value, x1 is equal to 1, because only one parameter is there, the entropy will be 0. Similar to this case. Correct? So how to combine them? A plus 0. I have to do A plus 0, but in a weighted form. So how A is reached by this 0? So there are 3 zeros out of 4.
I'm
That's
sorry
why
to disturb. Sorry to interrupt, ma'am. You say it is unclear because it is neither 1 nor 0. Am I right, ma'am?
which is unclear.
No, you have taken point to what it is point 8, and
I
then
have
you
not.
said it's not unclear.
I am saying it will be near about some values. I am just considering it. It will be giving you some values in points. It will be not
Yes,
in.
yes, yes.
That's why I consider that as A. मैंने यहाँ पर
Yes.
That's why I have chosen a variable to denote it, because I don't know the actual value. Right?
Yes, ma'am.
So I can consider that as A. That's why I have written here as A. Is it clear? Or if you have any doubt, then please go ahead. हेलो एनी डाउट? कौन पूछ रहा था? हेलो am I audible? Repeat again. Okay, look, let me give you another example. Let's take the same example, then only you are able to get this. Just consider this is your data. Okay, I have made an amendment here to just show you some results. I have this data. You know the formula of entropy, correct? So the formula of entropy is P1 log P1 plus P2 log P2, correct?
Yes, ma'am.
Yes, ma'am. Correct, because there are two classes, P1 and P2. P1 is denoting 0, P2 is denoting 1. Okay, is it clear? इतना समझ आया? Here I am saying P1 is denoting 0, this one, and this P2 is denoting 1, because I have label 0 and 1. Correct? Is it clear? Hello, hello. Am I audible?
Yes, ma'am. You are audible.
Okay. Okay. So
P1 should be probability of x1, right, ma'am?
then what is P2?
Probability of x2.
No. Probability P1 means these variables. If I am talking in Y, there are two classes 0 and 1. So P1 is denoting 0 class and P2 is
Okay.
denoting 1 class. I am talking like
Okay.
this.
Okay.
Okay. So in the last step, in which you all have done it completely, this step, this one. Okay. So in this step, what I wanted, I have calculated information gain over Y. So how I have calculated? I am not using here 2, I am using here 0, just to denote P1 and P0. Okay. So you know that value in this attribute, the P1 is equal to and P0 is equal to. Just let me know the values for Y attribute only. What is the value of P1 and P0 in this Y attribute?
3/4 and 1/4.
3 by 4, 1 by 4. Good, very good. Now this was your first step जो आप कर चुके. Next, in this step, I want to choose x1 or x2. So how you will choose one among these two values? You will say if some parameters, yeah, you have to select one, right? To select one, I want to have some values for both these attributes. So what I am going to do, let's say for x1, I will be considering these classes. Okay, so remove this. Let's say this is A, B, and B. Use this. This is maybe, let's say this is C and this is D. Now use these values, let alone 0 and 1. So what I wanted, if I am going to choose x1, I want to predict that what is the entropy of Y given x1. So because x1 has two values A and B, so I will be calculating Y x1 is equal to A, Y x1 is equal to B. Getting my point? Is this clear now? Is it clear? Is it making any sense? Now I am not using 0 and 1 in x1. I am choosing a complete set of variables. Is it clear or not? Okay, I am assuming because you are not responding back, it is clear. If it is not clear, let me know, because I can only answer your queries if you are not able to understand. I can redefine it everything, but if you are not going to acknowledge, then I'm
Yes,
not
ma'am.
able
We
to.
understand. Yeah,
Yeah.
understand, ma'am. Actually, you have taken only two variables instead of 0 and 1. Am I right, ma'am? So you
Yes,
have
yes.
taken only the left hand side you have completed.
Yes. So
Right?
basically,
Yes.
now I
Yes.
wanted to know that what will be the value of entropy given if I am choosing this A, or if I am choosing this B, or I am choosing this as a whole. So because choosing this attribute as a whole will be splitting into two parts, A and B. So I will be considering this A and B separately. So for this A, just because when you choose only A, only two rows will be chosen. You don't know any other row. I am talking about given x1 is equal to A. So I have asked you a question that I want to create a men's cricket team, then obviously all the females present here will not going to be considered. So I have no choice for them. So I will not consider B while calculating this portion. So I have only these two values, 0 and 1. So here also I will calculate P1 and P0. So P1 is 1 by 2 and P0 is also 1 by 2. So put it in this formula, you will get 1 because both are 1 by 2, 1 by 2. Okay, so this is the highest probability, highest information. That's what I have told you. If the probability is 0.5, then this is the highest information, highest randomness. That's why your information, this entropy value comes as 1. Okay, similarly, when you will choose x1 is equal to b, then you can see that here there are only ones, no zeros. It's a pure event. So for pure event, here also I will consider P1 is equal to 2 by 2 and P0 is equal to 0 by 2 and put in this formula. When you put this in the formula, you will get 0. So this is how you are going to calculate x1 given A, x2, x1 given B. So these are separate entropy values. One is one, this entropy value is here is 1, this entropy value here is 0. Now I want to combine it. Okay, so till now if you have any problem, then go ahead. So to combine this, how I can be combining it, because this is the value from A part, this is the value from B part, I have to consider the probability of these two also. So what is the probability of A in x1? It is 2 by 4. What is the probability of B in x1? It is 2 by 4. So combining it, I am going to use this weightage. So these are the weightage I am going to combine it. So what I am going to do, 2 by 4 into 1. 2 by 4 into 0 will give me the final entropy when I am using this x1 for y. So let's have the same concept for x2. So while choosing x2, if I am saying, let's say, what is the entropy of y given x2 is equal to c? This is first class. So because c is having 1, 2, 3 values, these values. These 3 values. So it means here I can say P0 is 1 by 3. P1 is 2 by 3. So now put this P0 and P1 in this formula, you will get some value. It means that value, neither it will not be 1, it will not be 0, it will be some decimal point value that you are going to get. So I am assuming that value as alpha. Now calculate the value when y given x2 is equal to d. So because it is only one row, here also P0, because we have no values, it will be 0 by 1. P1, it will be 1 by 1. And when you put it, entropy will come as 0. Here entropy is alpha. So take the weightage. How to take the weightage here? The probability of class C into alpha, the probability of class D into 0. So the probability of class C is 3 by 4. Probability of class D is 1 by 4. So what I am going to do, 3 by 4 into alpha plus 1 by 4 into 0. So this will be my probability at this stage for x2. Is it clear or not?
Yes, ma'am, it is clear.
Okay, so it
Yes,
means
ma'am.
that, right? So now it means that these are your points on which you want to make decision. So let's make some interpretation out of it. So we calculate the information gain here. Information gain is the actual entropy and now current entropy. It means that before choosing x1, the entropy was 0.8. After choosing x1, the entropy is 0.5. So what is how much gain I have taken here? 0.3. It means that if I am going to choose this attribute, the gain will be 0.3. Similarly, I would calculate the information gain for x2 also. Okay, so कहाँ गया आपका question? Okay, so the highest the information gain is, we choose that attribute. So in the given question, because it was initially the same value 00, means I have changed this to different class right now. At present, because the entropies are coming same, you can choose any one of them. But let's say this gain comes here as 0.2. So it means that this gain is higher. It means that choosing this attribute, you are getting more gain. Okay, so this more gain means you have to choose this attribute. Getting my point?
You can repeat
Yes, ma'am.
you can repeat the information
Okay.
gain.
Okay. So basically, how to interpret it? Just look here. So what we have done, we have just calculated entropy. Okay, entropy is information. So let's say I have 0.8 information in the starting. This is the starting information. This is this one. After choosing x1, I have the information 0.5. It means that agar if I am choosing x1, from 0.8 it is coming to 0.5. It means how much information I have used. I have total information 0.8. I have to use all that information, but I have taken this much information. So this is the gain for the information, right? So the more the gain is, it means that attribute is more suitable for you. Okay, so it means that, let's say this attribute gain is giving you 0.3. Here it is giving you 0.2. It means the 0.3 is more than 0.2. That's why you have chosen x1, not x2. This is how we choose the attribute to split first, because there are two choices for you, x1 and x2. Which attribute you will put on the root? So this is derived using this formula. So what you will do, you will first calculate the information gain, first calculate the entropy of target variable, then calculate the entropy given x1 or given x2, and calculate this information gain. Information gain is nothing, just the difference between the original and the current value. Okay, the more the information gain is, it means that attribute is giving you more information basically. Okay, so we will be choosing that attribute first. Okay, just consider, just think about this. I have, let's say, choosing x1, I have an entropy of 0. Okay, and choosing x2, example दे रही हूँ मैं, x2, the entropy is 1. Okay, it means that here the entropy is 0, means all the values are pure, correct? For 0 means the all values are pure. It means that if I choose this x1, then my all values are pure. I have to choose this x1 first. Just think about this कि मेरे पास दो attribute थे, x1 and x2. Using x1, I can choose, this is a sure event. Okay, so that's why if this x1 value here, this value is 0, the information gain will be 0.8 minus 0 will be 0.8. And this x2 is, let's say, 1, very random. So 0.8 minus 1 will be negative value. So I am telling you, the more the information gain is, you have to choose that attribute. So you will be choosing first this attribute so that it is able to involve more information. Okay, getting my point? Is it clear or not? Maybe we can have some more example for this. uh, This is the example.
Excuse me, ma'am. Now, final that example that we have just seen. So, how the decision tree will look like finally? I mean, the initial node and then decision node and then
Okay.
leaves. So, वो
Okay.
कैसे दिखेगा अभी ये
See,
example में?
basically, this will help you to choose your node. So let's say you have chosen x1. Okay. This is x1. You have chosen the root node. Now it has two possibilities, whether class A or class B. All right. Now at this class A, you have to choose another node. Now at this stage, because you are here at this position, this one, this position, your entropy initial is here. You will again calculate all this procedure and check what should be here, what should be considered here. So because x1 is already chosen, you will choose for x2. You have only second variable, x2. So this is how you, let's say you have three attributes, x1, x2 and x3. Okay, so repeat the process for all three and we get an information that this attribute is giving you the best split. So what I will do, I will choose this. I have chosen x1. A and B I have splitted it. Now for A, here the entropy is given as 1 from this area. Okay, so the entropy here is given as 1. Now my initial entropy is 1 here. I will be applying the same condition for x2 and x3. So I will choose where x2 is more suitable or x3 is more suitable. But because I have chosen A, so I will be considering only these two rows. I will not look for another rows. So this is how this if condition is applied. Just think about this. If I have chosen this step, I have applied this condition. I will again calculate all these things for the remaining data because I have chosen this. So if I am choosing this, I will be using this part of the data only. I will not choose another part of the data. If I am going in this direction, I will choose only the part where x1 is B. Other part I am not going to consider here. That's why I am telling you these are two separate regions. These are two separate regions because they will lead to two different leaves. So the number of leaves will give you different regions in your data set which are mutually exclusive. They are saying that this part of the data will belong to this region, this part of the data will belong to this region.
Yes, madam. Yes, thank you.
Okay. Any doubt?
No, no, no.
Okay. All right. So basically, this in the similar way, for Gini index also the formula is different. So for the Gini index formula, this is for two class formula. Okay. So you can use the same class formula. K pk into 1 minus pk. Don't worry. Use this formula. Just that you have to use this formula in place of entropy. The other concept is extremely similar. So what you can see here is if you have this data, I am giving you this data in which 6 positive and 4 negative classes are there. So it means the attributes name or the variables names are completely changed. Okay, so using this, if you have to calculate the Gini index, you have to use the same thing. You are using it here, Gini index. Now there you have used entropy H, the same, the parent node Gini. So this is for your final attribute, this one. Now you have to calculate Gini index for color and sizes. This is like x1 and this is like x2. So what you will do, given x1 is equal to red, given x1 is equal to blue, given x1 is equal to green, you have to calculate it. So look here, Gini index for red, Gini index given blue, Gini index given green. So after this, you have to calculate this Gini index, take the average, similar average you are saying, you can see here, similar type of averaging is there. Right, similar averaging is there and now it is 0.48 minus 0.41. It means every process is same, just that the formula is different. There you have used the formula H is equal to in some summation of T log P, and here you are using the G is equal to summation P into 1 minus P. The difference is this, that's it. Otherwise, there is no difference. The same formulation is there, the same maximum value is to be chosen. It means from here and from here, this is chosen. This is maximum. So gain is 0.8. So here we say it is Gini gain, there we say it is information gain. So both the procedures are same, it's just that the formulation is different. Okay.
Understood, ma'am. Understood.
Okay, so you can go on with this example also. Thing is, that's why I told you in the initial phases, it's not difficult to calculate. It's just that it will test your patience. Because one missing value, thinking about ki in this branch we have to consider only this data, this is not easy as a human to understand. And if I am going to give you some small data set with two attributes, it will take this much time. Just think about, if I am going to give you 3-4 attributes with multiple classes, it will take time and your full consciousness there, right? So if you want to try, don't worry, you can try it. You can solve the complete question, you can send me on email, I can recheck it, I have no issue. But this is more convenient with the help of programming, it's more like that. And secondly, as I told you, these formulas or these decision tree application is not into much more, means we are not using it for our data, which the data which we are using it today. So that's why this concept of Gini and the concept of entropy is very important. That this entropy is giving you an information about the whole data, and how you are going to choose the variable, how you are going to choose the attribute. This is what is more important for me, which I think. Okay, after this, this is a complete example, you can go and search it, and after this it is nothing. This is all I have discussed actually. It's not like that ki, it's more like that I have already told you ki if there are these many classes, we can take a split. If there are q classes, then we can take q minus 1 split. One split is this is no red. This is, then we are combining red and blue in one split. It means it's more like that, how to choose the split, there are multiple ways. You can just go through it, it's not a difficult job to go by this. Okay, the another thing important is bagging. Actually question is ki if we are going to if you are increasing some amount of data after training, it means it can lead you different type of trees, because each row is contributing for creating this tree. And if you are, let's say, if I remove one row, okay, the probability will be changed, and obviously your tree will be changed, your splits will be changed. So there is a concept of bagging comes into picture. So what bagging does is, bagging means create bags. So what I am doing, I am creating multiple random subsets of the data. So let's say I have 100 total rows, I have 5 data subsets. So first subset is of 50, second is of 50, third is of 50, fourth is of 50, and let us say fifth is of 50. So these are, I have chosen some 50 random rows here, I have chosen some 50 random rows here. So these are not mutually exclusive, they can be repeated. Okay, now what I am doing, train a tree here, train a tree here, train a tree here. So it means you are training separate trees. So because you are training separate trees for separate split of data, it is called random forest. And after creating all these trees, what we will do, we will pass the data from here, we will pass the data from here, from each and every fifth. If here are 5 splits, you can go for these trees and take the output as the majority of these 5 attributes. So it means that there are 5 models. So this is your model 1, this is your model 2, this is your model 3, this is your model 4, and this is your model 5. So maybe from one model you get a output of class as A. Second, you get an output as B. Third, you get an output as B. Fourth, you get an output as A. Fifth, you get an output at A. So what you will do, you will choose the majority of this. So you will say, out of these 5 models, if I am giving my data, it is giving me the highest majority as A. So means this particular row will be defined as A class. So decision tree is not generally used singletonly. It is used in the concept of random forest as a bagging ensemble method. So ensemble means you are combining the knowledge of multiple models all together. So it's more like that ki, let's say if I ask you some question, you are here 15-20 people. So if I ask you some question, if I show you some animal photo and I ask you whether it is belonging to class A or B, so some of you will be like कि हमें तो पता नहीं है, let's say in a random way. Some of you may be knowing it, some of you may not be knowing it. Okay, so I will take, because I want to take the final answer from your class, I will take the majority from all of you. So consider that you are trained on different subsets of data. Okay, data is present in this whole world. Maybe some subset you first person is trained from, the second subset maybe second person is trained, maybe you have the two-person have seen the similar books, right? So you can consider like that. So if you are trained on different subset of data, but your model is same, your neural network is working same, it means because in your brain there is single algorithm, that is neural network is working. So it means that model is same, technique is same, it's just that data was different. So what can I do? I can take all of your consideration, all of your outputs while considering any question. So I will take the majority and say ki, okay, majority of the class is saying that this photograph of an animal belongs to class A, I will consider it as class A. So this is how we are using decision tree in random forest using bagging. So this concept is called bagging, because what you are doing from this whole data set of 100, it is considered as a bag, and you are just randomly taking out some 50 random samples out of it. That's why it is called bagging. So this bagging and other ensemble techniques we are going to discuss in detail actually. So here is one more example is given to you. So multiple examples are given in this PPT, so you can go through it, and the questions are actually relatively easy in this week, because so this is what about decision tree in this class. So if you have any doubt, then go for it. Any doubt? Okay, then we will meet next week the same time.
Okay, ma'am. Upload. Can you please upload this PPT today?
Yes, I will be uploading it in half an hour.
Okay, thank you.
Thank you.
Okay, Shreya ma'am, thank you.
Okay, okay, thank you so much.
Lot of patience you answered.
Ma'am, there was a question in the last assignment was not, there's some discrepancies.
uh, Please let me know which are the discrepancies.
Last assignment actually. So can I send a mail to your address?
Yeah, sure, you can share me an email on my address. I can share my email address again. Yeah, this is my email. You can send me the email. I can look it out, that what are the discrepancies, and revert you back. Okay. Okay, all right then. Thank you so much.
Thank you, ma'am.
Okay, all right.
Thank you, ma'am.
Thank you.
Thank you so much.